Hi. This is a quick announcement before you start watching that video that we're going to cover that exact same topic in tomorrow's class as well. So you can join our class using the link in the description, and I'll see you in the class. Okay, so today we're going to be learning conditional probability. Now remember, conditional probability is different from normal probability, okay? Because it's followed by a condition. So for example, if I write it here, let's say the conditional probability of, let's say, A given B. Okay, let's say A given B. Is probability of A happening given that B has already happened. This is what conditional probability is. Conditional probability of A given B is probability of A happening given that B has happened. So the condition over here is that B has to happen before A can happen. Okay. Now another thing you want to keep an eye out for is that when you have questions that say without replacement. Okay, I'm going to explain what that is. Don't worry. Be aware of questions that use the statement basically. Without replacement. I'm going to get to that, what that means. That's the second thing you want to be aware of. And the third thing you want to know is that if A and B are independent, so this is linked to the previous video. If A and B are independent, then probability of A given B, meaning the condition probability, is equal to probability of A and probability of B given A. So this is all related. B given A, and in the end, this is all gonna be equal to, write it here, 1 second, probability of B. So probability of A given B is the same. Let me put it here. Probability of A given B is the same as probability of A and probability of B given A, and that is same as probability of B. So these are the things that you need to be aware of. Okay, 3 points to keep in mind. Let me mark it here with a pen. To keep in mind. Okay. Now we're gonna learn how do we actually find the conditional probability. This is gonna be linked to a previous video that I did that was about the AND rule. Okay, we're gonna use something similar to that for conditional probability. Okay, I'm gonna leave the link to that video over here as well. Now, if you want to find the conditional probability, we have this formula: AND rule for conditional probability. And we're gonna see what the formula is. And remember, probability and even statistics, it's not that hard, but the thing is that it's a lot. Okay, like if I give you one name to remember, it's not a difficult task. If I give you 1,000 names to remember, it's a difficult task, not because remembering names is hard, it's because it's a lot. Okay, now what's the formula? The formula is probability of A and B is going to be equal to probability of A multiplied by probability of B, no, probability of B given that A has happened. So this is your formula, and you have to know the conditional probability to actually find out A and B in this case. Now let's look at a question to understand the concept. Earlier either watches TV or reads before bed. The probability that she watches TV is 0.3. If she reads, the probability that she is tired the next day is 0.8. What is the probability that earlier reads and isn't tired the next day? Okay, so what do we want to find? Let's write that down. Probability of reading and not tired. Not, let me make it a bigger T so we can understand it. And not tired. Okay. Read and not tired. Now, what do? Probability of A, that is probability of reading. What's the probability of reading here? The probability that she watches TV is 0.3. That means the other is going to be the probability of reading. So 1 minus 0.3. 1 minus 0.3, 0.7 probability of reading. That's this. So 0.7 multiplied by what? The probability of B given A has happened. B is what? B is not tired given reading has happened. So if she reads, okay, so that has happened. The probability that she is tired the next day is 0.8. So that she is not tired will be 0.2. Not tired. Because remember, probability always has to add up to 1. So if we know 0.8, we can subtract that from 1 and we get 0.2. So that's going to be 0.2 in this case. Okay, found that out. Now simply multiply it. How do you do that? Take this on the side. You have 0.7, 0.2. Let's pretend that this is a paper 1 question where we cannot use a calculator. 7 times 2, 14. You get 4, 1, 2, 0, 1, 0, 0, 0, 0, 1, 4. Then you have 2 decimal places and you get 0.14 as your answer. So that is a probability. Now one last thing that we need to do. For conditional probability, we've known how to find the answers. But what if we want to find conditional probability on a tree diagram? So we're combining things. Let's see. Conditional probability on a tree diagram. And we're going to understand this from a question. Let's see. 1 second. Okay. Now let's see the question. A box contains 5 red discs and 3 green discs. So in total we have 8 discs. 2 discs are taken at random without replacement. What does this mean? This means you will not put the discs back after taking them. So that means it will decrease every time you take one. Okay, so find the probability that both the discs are the same color. Now remember, same color. So that means we can have 2 red and 2 green, but not red and green or green or red. Okay, now let's say I take the first one as a green, the other one also as a green, and green here. Okay, let's make the other one for the red. I take a red, I have another red, and I take a third red. Okay, now we have these different scenarios. Okay, that I take a green, then I take another green, I take a green, I take a red, I take a red then green, and take a red and red. What do we want? We want the probability of these 2 greens and these 2 reds, because we want to find the same color probability. Okay, now let's say I take the first one. The total discs are 8. Okay, so the total discs are 8. Now if I pick a green disc, what's the probability? I have 3 green discs, so that's going to be 3 divided by 8 probability, and the remaining will be 5 divided by 8 for the red discs. Okay, now this is where the without replacement comes in. If you take a green disc, that means that you're not going to put it back. So now the total is decreased by 1. So now the total amount of discs is 7. Okay, let's say you pick a green disc. Now the probability of picking a green disc again is what? 2 by 7. Why 2 by 7? First, you took out a green, so the green has reduced by 1. So now we have 2 green discs. And you also did not put it back, so that means 1 is also decreased from the total. So we have 7. And how much for this? We did not take out any red disc, so that means 5 is still going to be there. But because the total is decreased, so it's going to be 7 instead of 8. Same thing here. If we took out a red disc, the red disc will decrease by 1 and the total will also decrease by 1. But in this case, because we did not take out a green disc, the green disc will be 3 divided by 7. These are our probabilities. Now, we want to find out for the same colors, okay? For the same colors. So we have the same colors. Let's see. First we have this, the green and green. Okay, we're gonna go from this route. So that's gonna be 3 divided by 8 multiplied, because it's the same branch, 2 by 7. So it's gonna have 6 divided by 8 times 7 is 56. Okay, so we have 6 over 56. Now this is just one. The second method is that we have red, red. Okay, let me also write this here. Green, green, and red, red is here. Okay, now for red, we have 5 divided by 8, and then multiplied by 4 divided by 7. Okay, what do we get? 20 divided by 56. Now, because these two are in separate branches, we're going to add these answers. So, same color is going to be green, green plus RR. Green, green is what? Let's wait a minute right here. Total probability is this. Okay. Now, 6 divided by 56 plus 20 divided by 56, we get 26 divided by 56. If we simplify it, 2 times 13, 2 times 28, that is our final answer, 13 divided by 28. If you watched the video till the end and you still have some questions about the topic, we're going to cover that exact same topic in tomorrow's class, and you can join that class by joining the link in the description. Okay, I'm going to see you there.